I'd like to call onto the stage my fellow panelists. So number one, I'd like to call on stage John Ara. Please clap for him as he comes on stage. I'd like to call on stage Michael Michier. Please clap for him as he comes on stage. Sean Owoye. Please clap for him as he comes on stage. And lastly, Mutembei Kariuki as he comes on stage. Just have to sit anywhere.
I'm fine. Okay, let me take it.
It's fine, thank you. Yeah, so thank you so much, gentlemen, for joining me onto the stage. I think the first place you can start off is a round of introductions. So I think I can start with you, Mutembei. Please state your name, the company you work for, and your specialty. Thanks.
Thank you. My name is Mutembei Kariuki, and co-founder and CEO of a startup called Fastager. We're building a Web3 platform for commerce where we help SMEs to understand the data that's coming into their company so that they can understand their customers better and so that they can engage with them using coupons and tokens on a blockchain, which at this moment is probably not the best thing to be talking about, but I'll explain more later. And so my specialties are particularly around data analytics and also blockchains. Thanks.
Thank you so much. Next, Mike, can go.
Good afternoon, everyone. Michael Meshi. I'm the CTO at Solve Kenya and Standard Chartered Venture. We specialize in B2B marketplace for SMEs. My specialty, I think it's just technology. I don't like picking a spot.
Thank you so much, Mike. Sean?
Good afternoon, everyone. I hope you can hear me. My name is Sean Owoye. I know most of you guys actually call me as Sean. I work with IPSL, home of Pesalink. I've been working with Pesalink now for about 3 years. Prior to that, I was working with a company called NIPS in Nigeria. Basically, I lead technology and operations at IPSL. It's a pleasure being here today. Thank you.
Thank you so much. John?
Hi, everyone. My name is John Kumar. I'm the founder of Ardenian Labs. My specialty is building stuff.
Thank you so much, John. I think we'll start with you then, John. And I think the best place you can start with such kind of a topic is just demystifying how we use ML and AI for fraud detection. So for the purpose of bringing the audience up to speed, how are we actually applying AI and ML methodologies in fraud detection?
Thanks very much. You're more of the expert, but I'll just try. Basically, obviously, over time, one of the things that we've always collected in any sector is data. And in financial service sector, data is really the core of everything that you do. And one of the first things that, while I was working as CEO of one of the leading AI companies in South Africa for quite a few years, you guys were one of our clients, was really how to, first of all, structure your databases that is actually machine learning ready in the first place. Because, you know, most institutions have a lot of data, but most of this data is unstructured and is really not readable or wearable in any way to actually allow you to achieve the optimal use of that data. And that is the first thing that you have to understand. Even if you start looking at fraud detection, let's take credit cards, for example, the data that is coming into your data sets and how you model those data sets, and then what kind of patterns do you want to generate from those data sets. So, you know, from the baseline of just understanding the structured nature of data that you actually want to use for us, you know, to the size of the data, to what the data sets look like, to what they say, then obviously what is the pattern that you'd like to recognize? What are the patterns and models you like to create on those patterns before you even start looking at some of the tools, you know, or the metrics or the laws? Do you want to use a Brentford law? I like genetic algorithms, which is one of the laws that I used to use a lot. When you start then trying to model data sets into, most of the time, a supervised machine learning engine. So I always say, for the purpose of just starting the conversation, is really first to understand the structure of the data that you are collecting, how that data is structured in the database, and what the data actually allows you to do, first of all, before start looking at what it is that you want to build. So in fraud detection, it's so important because you're collecting, several types of data of just one particular type of asset, which is the card, for example. There's so many data sets that you collect from a card. That means that and that card is tied to an individual, is tied to a KYC, is tied to all these other things. So I'll give you an example. I was once somewhere and someone was using my card in India. But the machine understood that I never really go to India. I never really go to Asia because my pattern had been recognized as an individual in the dataset cluster. So in the bagging cluster, it actually recognized my pattern, and instantly they hit me up and say, "Are you in India?" Like I've never been to India in the past 3-4 years, and instantly. So that was one way for the ML tool to quickly recognize that there is a misinterpretation of the pattern of this person and of the way my card is used and how my card is used, what is being used for, because they started training their engine to understand the value of the clusters of each client. So that's how I would start it.
Yeah, interesting point, John, you bring to the conversation. Number one, you are very keen to highlight fraud detection, which is through using machine learning algorithms in the card space. Maybe I can just call on to Mutembe to chime in here. What about fraud prevention? How are we actually adopting ML technologies for that as well?
So thanks for that question. Thanks for that question. So usually we keep on talking about fraud detection, but there's a side of preventing it and also predicting whether it could happen. So there's usually those three areas we should be looking at. So in terms of preventing, there are a lot of times where it's all about, again, data, as was mentioned. If we can be able to collect enough data. So for example, if you're looking at a context like in Kenya, yesterday actually we were listening in the morning in one of the sessions, the conversation about the fact that in Kenya over 60% of the fraud is within the country, while, for example, in Nigeria, it's only 35%. And why is it so much more prevalent here is because we have an enabler in M-Pesa, right? So a lot of fraud actually happens because of M-Pesa. So if we were to prevent it, then the whole idea would be, how can you collect enough data so that you can be able to label, okay, what are those transactions or those messages that would be coming in on your M-Pesa asking you to do something that would most likely be triggered as inauthentic, or in the case of fraud or phishing. So it's all about the amount of data we have. And I think one of the challenges right now is if you're supposed to build like a prevention mechanism, one good example is probably when you use Truecaller, right? Truecaller has been able to crowdsource people labeling certain numbers as spam or scammers. And then when you're getting a call from a possible scammer who's probably going to engage in fraud with you, then it highlights, okay, this is possibly a scammer. So that's one of the ways of collecting enough data, getting people to label that data. In this case, it's crowdsourced by Truecaller. And within a bank, one of the things that could happen is, since a lot of banks are already engaging with M-Pesa, is build data sets and pick out which one of these messages is most likely to be fraudulent, and then train a model, supervised learning most likely here, and to be able to detect, okay, at one particular time, this could be something, and then the AI now, so once you've trained it to analytics, and then the AI stops any transaction that's about to happen. But now the challenge there is, how do you, I think you're going to get to this at some point, is like, how do you end up creating a good customer experience where you're not just blocked from a transaction when it's false? So that's also a big thing to think about.
Yeah. And it's great to just bring that aspect of a company like Truecaller being able to actually democratize that ability for people to get value out of fraud detection. If you're going to focus on the benefits of use of ML and AI, I'll call on to you, Michael, to just take this question. What are the benefits comparing to the previous way we actually ran fraud detection in organizations, whereby you had different teams going through different Excel sheets and databases, and now you have adoption of a new technology that is promising more benefits? What do you think are the merits of this adoption compared to the previous regime?
Thank you. I think the first and obvious benefit is the fact that you're going to have real-time detection and prevention. 7 years ago when I started working, I used to see auditors go through yesterday's transactions, trying to detect if any of these ones was a fraud, and that doesn't serve the customer any benefit. So now that we have able to train AIs to detect, sometimes they do have the false parts, but you're able to detect this could be a possible fraud, and it's able either to prevent it or even predict that likelihood, then now it becomes much easier. Again, no set of humans, as many as you can get in a room, will comb through data or transactions as fast as AI. So yes, there may be a few false positives in the beginning, but now you're going to have more accurate findings. You'll even be able to establish patterns. Generally, how our brains are structured as humans is that we look for patterns in things. It's cold, it might rain, I should wear a jacket. That's just, we have a linear pattern way of thinking. And then that applies to, as a bias to the AI that you're going to build. So it's also going to look for patterns in the fraud and then use that to predict possible frauds. If I use my card, for example, if it's John's example, for India, if the card goes into the ATM, it shouldn't even ask for the PIN. It should be like, all right, this must be a duped card. This could be a card that has been skimmed because the last time you used your card was 2 hours ago in Nairobi. So there's no way, logically, you've crossed that distance. If it's an online payment, I've seen areas where just the AI can, and if there is enough data, of course, about you. If you're making a purchase, let's say you're buying something on Amazon, yet you're buying from the .uk domain instead of .com or the US version. So should it really block you because of that regional restriction, or is there enough data for it to be, if I block this is a false positive? Yeah.
Thanks. Thanks, Michael. Sean, I'd like you to take this following question. And most people in the audience right now are thinking, how do we actually deploy capacity to actually be able to develop ML and AI technologies to help with fraud detection? So walk us through the journey. So how do you do it? Do you actually leverage on existing organizational skills? Do you get vendors to help you? What's your recommendation with regards to building this capacity and realizing the benefits of use of ML and AI?
Okay, thank you very much. I think AI and ML technologies are just being hyped beyond how they need to have been used or how they should be used. What do I mean by this? You see, when you look at the banking and financial services industry, it's a whole ecosystem on its own. So an institution implementing AI or ML technology cannot be sophisticated as having it jointly as an implementation of the ecosystem. And let me give you a case. So let's say Bank A, for instance, or Financial Services A or FIA has implemented, deployed, invested in multi-million-dollar AI machine learning technologies. The consumers and the customers of that institution, they are going to use account-to-account rails. The customers and of that institution, they are going to use card rails. The customers and consumers of that institution, they are going to issue checks. Consumers of that institution, they are going to issue instructions against EFTs, RTGS, and all that. Now, if you look at all those different platforms, there's a tendency that, yes, there might be an element or a component of a fraud being perpetrated across all those four rails. Now, how do you now detect it if you've just implemented as an institution? Of course, you have everything to be able to do some sort of descriptive analysis. You might not be able to predict in the sense that you are looking at it from two-way, flow, where it's coming from and where it's going. It's possible that where it's going is actually a fraudster. Now, you'll not be able to now look at it from end to end and be able to say, even we've deployed these technologies within the institution, how is it being used across the ecosystem? Because if you look at banking and financial service ecosystem, you're expected to actually monitor fraud and detect fraud from the point of initiation and up to the point of consummation. So if I'm sending money to you, for instance, I should be able to have the entire stream being monitored to actually engage and see the traceability. How many times has the recipient been a fraudster or received fraud proceeds? Now, that means there's going to be a link between myself and the person that's actually been receiving fraud proceeds. So if it's been implemented, if all those technologies have been implemented in silos across different institutions, we might not be able to actually get the true, maximize the benefits of the technology, rather than seeing it more from an ecosystem point of view. Now, deploying capability and capacity around this, I think first and foremost, there should be like a kind of joint industry collaboration. And I'm going to give a case where I'm going to give a comparative analysis of what is happening in Kenya and what has happened in Nigeria. Now, in Kenya today, we have M-Pesa contributing about 90-something% of the real-time payment ecosystem. So you see more like a kind of closed-loop ecosystem. The same platform facilitates initialization of transaction, processing of transaction, and finalization of that same transaction. So any AML or AI technology that has been implemented is within the closed loop. Now let's now take it on the flip side on the banking ecosystem, where we have about 42 banks. How do we manage end-to-end from initialization, processing to fulfillment? It's very, very difficult in the existing market. Now let's now look at what happened in Nigeria. The federal government of Nigeria initiated what we call NIN, Nigeria National, just like our national ID here. But in like 2 years, it didn't take off. So the banking industry came together and say, I think this issue of fraud, we need to actually take it as an industry. So they mandated NIBS to actually come up with what we call a BVN, biometric verification number. Now, how does that BVN works? If you have a BVN number, which is linked to your biometric details, your facials, your fingerprints, and all that. Now, if you have account numbers in 10 banks, that unique number is actually linked across those 10 banks. Now, that means if you're a fraudster in Bank A, you are going to be flagged across the 9 banks. So that means even if the other 9 banks, they are not cooperative enough, definitely you actually you only be detected in Bank A. The remaining 9 banks, you not actually have visibility of your status as a fraudster. Now, what happened and what the implementation has actually helped now to do is that if you are a fraudster on account-to-account rails and you move money into card rails, you use your card, because fraudsters are very, very smart. They will use separate rails to actually launder funds, and they will use another rails to actually move it out. You've seen cases whereby I send money to your account, you take your card through, let's say, a PesaLink platform, for instance, you take your card and you go to the ATM immediately and you withdraw cash. So the traceability is going to be very difficult the way we have it now, except we now start looking towards having more of like a kind of industry collaboration so that we can be able to harness all the potentials of those technology end to end, or else we'll just be implementing those technologies in silos and will not be able to have the full achievement that is desired as an industry.
Thank you so much, Sean. So industry collaboration,
yeah,
and learning from each other.
Yeah.
John, your thoughts about capacity building? I know your organization is actually trying to recruit and train thousands of ML and AI engineers.
I mean, for me, I think I'm not a banker, so I've never worked in a bank in my life, first of all. So I come from a completely different perspective around this. Machine learning, data science is critical to the future that we are, which is we're in that future now, either we like it or not. Data is being processed everywhere. That data has to be used for either social human good. I'm part of the International AI Committee with the United Nations around AI for Good. And you can see how the use of data is also helping multiple industries. So not having the right skill sets is also a problem to being able to create an ecosystem, because if you don't have enough people who really understand how to really be machine learning experts or how to actually, build AI models that make sense, then, it doesn't matter how much data sets or how many people come together, you're still stuck. And so talent development is a critical part of having to build an industry that can thrive with the value of ML. And one of the things that we focus on is how do we develop more data scientists here? How do we develop more AI engineers? And for me, the way that we look at that is we do it via a proof of work model. We try as much as possible to stay away from theoretical facts, and just basically over the programs that we do, we just give you hard work to do. And by the time you're done those hard work for 4 or 5 months, you truly are a junior machine learning expert. So we can take you from just being something completely different to literally, because we see a lot of people who come out of university, they've studied data science, and you give them basic models to build, they can't build it. They can't do, but they understand the theory, non-stop, end to end. They can quote the theory for you. They even get jobs. They still keep quoting the theories, and I've seen that in so many companies that I've gone into. So running the proof of work program, which is what we do now, has allowed us to build machine learning engineers, which a lot of them we've trained about 149 now since last year, and about 102 of them actually work internationally for companies now, but sitting here in Kenya. So training the talent, but training the talent in a way that actually says, Hartnell and Afsa, give me real life work for these people to work on, rather than trying to bring them through a school of, this is what you're gonna have to do. So that's one of the things that, I'm very, very passionate about, because having lived in South Africa, especially in Cape Town for a long time, I saw the impact of training the right talent on developing. When we built, precision mortgage products in South Africa, it was purely because we understood a lot of the talent that we needed was in-house to allow us to do that effectively. So I definitely think the industry should come together and actually invest in training talent. And you guys should really, really invest some of that money in training talent here locally. Honestly, that's my parting shot to you guys.
Thank you, John. I can ask one more question to Mutembe regarding false positives. Now, when you're actually converting the manual ways of fraud detection to now being automated, there's an issue about false positives, whereby you've trained a model and you're actually flagging a customer walking into the bank as being a fraudster. So how do you handle that? How do you have that balance of ensuring that you don't actually flag the wrong customers who are just visiting your branch to deposit some money?
Okay, thanks for that question. Now, there's the idea that AI can be looked at in 2 ways. So as autopilot and as co-pilots, right? Autopilot is when you just, it's the AI doing everything. But the reality actually in most industries is because AI is not general intelligence, it's very specific. So the idea now is to use AI at what it's really good at, picking repetitive tasks, taking in a lot of data. And I think Michael also mentioned that there's no way you can maybe put a room of like 1,000 auditors who will be picking through different lines of account information to pick out what's fraud. So where we can use machine learning and current AI, which is very particular right now, is in helping the human being be able to process tons of data, so that what is already a very regular thing. So for example, so we have an interesting perspective as a company, because we started off as purely a data labeling company. So we started off purely labeling data for fintechs, for example. They'd send us tons of M-Pesa data, and we'd label it and build scripts for picking out different insights in that data. So that process could work really well where, for example, if it's Visa, every time hundreds of millions of people's and transactions around the world are happening, it's just picking out information about the different patterns of different people. So that in one particular case, I remember this was an example that we were being asked about is that, let's say you have 2 customers. One of them has gone to the bank and made a transaction, and then went on the expressway, got to the airport, in 10 minutes, caught on a flight and went to Mombasa. That's in about 45 minutes. And then uses the card there. But if you had given a very rigid instruction to the model that anything that is geographically in a certain distance should be flagged, that person's transaction will be flagged, while someone else who they were here in Nairobi, made a transaction and then drove a couple of hours to Mombasa, and then you expect that should be the norm. So those are 2 people who should be treated completely differently. So machine learning can be used for just going through tons and tons of data, and certain parameters work well. So that's a co-pilot situation. And then humans and other ways of getting machines to go through other data and understand that these different scenarios should be used so that we can create a situation where we don't end up creating a situation where a customer ends up getting, being viewed as a fraudster when it's actually his card, right, or her card that's happening. So it's a whole case of at the beginning using the very narrow AI to sift through tons of data. Then as the AI continues learning in the future, then we can be able to deploy it in situations where it'll be able to predict and know that, okay, in this situation, it's factored in the fact that, someone could have gotten on the flight, picked alternative data from probably the phone. So these edge devices that pick up geographical information. Let's say you also had your, let's say, StanChat or Stanbic app on the phone and could have picked up your information on geolocation and known that you've moved to a different place, and that's connected also to your card. So it's all about being able to increase the parameters of information that you can get in terms of metadata as well. So if we are able as financial institutions to make more use of even more data than just very narrow bits of data that we're collecting, then we can prevent situations where the customers in the financial institutions end up having bad customer experiences that could lead them to not working with that particular bank or switching. So technology, in this particular sense, it's all about right now helping AI make decisions that are better over a period of time, and then using it to go through tons of data. So it's a co-pilot situation.
Thank you so much. If you want to chime in, Mike?
Slight disagreement, or not complete disagreement, but I feel it is possible to get AI. It does take time, but you can't get AI to not have false positives or to reduce those false positives to the point it's near human level. Remember, AI is just trying to simulate human thought or intelligence. So when you come to something like general intelligence, we are miles away from that. But when you're looking at some of the cases you've given, once there's enough data, then you can be, as long as you ensure that the data that you're giving it is correct data, then what the AI learns, would that effectively be correct? And it would be making the right decisions. I know it's an ethical route to have sort of what we call a man in the middle, so that you can then overrule an AI's decision. But that just feels like you build a tool to stare at, not to use. Essentially, if you're going to build something that's as smart as you or smarter than you, makes better decisions than you, ideally let it make that decision. And it goes back to, because we have the black box paradox with AI, where we get the data that we put in, we get the result, we never get to understand how the AI learned through all that data, and we can't unteach an AI. So if we get the data right, then we don't need that secondary co-pilot. We can literally let it do that, because we've seen malware that's AI driven, very intelligent malware for our time right now. And you can imagine now weaponizing that to commit fraud. So it's a very well scripted AI that's able, once it's infiltrated an organization, it's able to know what are the fraud detection rules you've put up, because you're probably not using an AI. You've just said Fridays transactions above 50,000 should be flagged, and probably require an OTP or something of the sort. It'll come in there, learn those rules, and figure out a smart way to bypass. Then if you add in a human at that stage, what if you're not in the office, or if the team is too small? Okay. Yeah.
So interesting views here, whereby we look at how do we augment AI, but also giving it the right kind of data parameters to actually be able to be accurate at an acceptable level to do the right detection and prediction. John, I'll call you in, and at the moment, we'll take 1 or 2 questions from the audience. So anyone with a question can be coming to the mic. John, please.
Yeah, I mean, I think, can you hear me? I think I do agree with, because I think really going to, when you go from AI to deep learning, and you really want to train unsupervised autonomous engines that really perform machine learning, then you have to train them with different multiple sets of data. And it's a question of how much data you train and how many scenarios that you've created, because this machine is faster than you. It's processing information quicker than you can ever process it in milliseconds. So the more you train it, the more data you give it, the more it actually presents to you scenarios that you can't even compute in your head. So that same scenario, it will present to you in multiple different forms. That even allows you to begin to see like, wow, okay, this person could have driven to Kisumu and from Kisumu to here. It present all these different scenarios to you that allows you. So it's really a question of how much, when Sophia the robot, just for example, the chief data scientist for Sophia the robot is now part of our team. And when he talks to us about the amount of data they've used to train that autonomous engine that is called Sophia, which is smarter than pretty much all of us in this room, over 3 years, you'd understand when it looks at data, it can predict before even things happen, because it has run 1 million type of sequencing in real time that we can't run. So even that, and when you put a human, then you're talking about biased AI. It's the same thing as building a bias code into the machine learning anyway. So, I mean, I think yes, but I think on the long run, if we really want to harness the power of machine learning and AI, then we're going to have to learn to train, that's where I stand, machines that really are extremely intelligent.
Thank you, John. And you bring an interesting insight. Models these days have billions of parameters. Take an example of GPT-3, which is able to write a full poem and a movie script in less than a minute. Thank you, guys. That has been
you mentioned.
Last parting notes to Sean, then you can wrap up.
So basically, just to wrap up, I know we have a lot of CIOs and CTOs, in the room, and my point of view is to emphasize on how best you actually want to invest in this technology, and what exactly is the use case or business case that we're actually using that to solve. Are we trying to invest in the technology to use it collaboratively, or we just want to invest in that technology to actually use it in isolation? For banks today, I know a lot of us, we normally do a lot of sanction screening and all that. So the question is, where are we getting the source data from? We'll be talking around UN sanction screening list, AML checks and all that. A lot of banks today, they're also seeking ways to see how they can have a centralized infrastructure that can actually enable them to perform this, this exercise or this activity without necessarily investing so much. So in as much we are actually looking at investing so much in AI and ML technologies, we also need to be able to define and be able to have that foresight. Either we want to be using it isolatively as an institution to be making more of detection, prediction and all that to specific consumers, or we also want to look at it collaboratively as an industry. So it depends on how we actually juggle it, and we see how we want to implement it as an ecosystem.
And that's one of the best consultancy answers to most questions. It depends. Yeah. Thank you so much for your time. I'd like to thank the panelists on the stage for sharing your insights. And I think we can wrap up at this moment. Thank you so much.
Thank you.